So after filling these tables, so the first table is when we do the base, change the base, keep the exponent as 2. Second column is when we make the exponent -2. And then the third column is when the exponent is 1/2. Now, the first question that we're going to look at is compare the entries in the first and second column of each table and describe the relationship that you see. So if you're comparing the entries in the first and second column, what can you tell me? How can you compare them? What's the same? What's the difference? So the answer is the same, just for the negative exponent, it's the reciprocal. The reciprocal, right? Did we expect that? Did we expect that? Yes, because we know that if we have 3 to the power of -2, eyes on me for a second, 3 to the power of -2, that's the same thing as 1/3 to the power of 2, right? And what's 3 to the power of 2? 9. So that's going to be 1/9, right? So that's why when I have a positive exponent and a negative exponent, they're the reciprocal of each other. So it's 1/, whatever the answer is, right? I didn't even have to think. I know this, right? When I make it to the power of -2, I know that I'm just going to write it as 1/1/1/1/1. Okay? Now, compare the entries in the first and third column. What do you think it means to raise a number to an exponent of 1/2 or 1/3? So what do you notice about the similarities and differences between the first and the last column? Square root of the first one? Huh? Cube root for the second table. So when I raise it to the power of 1/2, it's the same thing as doing square root. Yeah? Does that make sense? Is the square root of 9 3? Is the square root of 9 3? Yes. Is the square root of 16 4? Is the square root of 25 5? But instead of writing square root, what did I write? A power of 1/2. The power of 1/2. So that means if I do 36 to the power of 1/2, it's the same thing as the square root of 36. Why is that? Square rooting is the opposite of exponent. Of exponent 2. Okay, look at this. If I had x squared and I want to get rid of the square, what do I do? Square root. And then what happens when I square root? They eliminate each other and then I end up with x, right? Now, this is what we've learned. Now, what's the math behind it? The math behind it is I have x squared. I raise it to the square root, which is actually 1/2. Same thing. Square root, and we just looked at that, right? We just looked at square root and the power of 1/2 are exactly the same thing, right? So now, we learned that power to the power is what? What do I do here to power to the power? Multiply. What's 2 times 1/2? Is 1, right? That's why the square root and the square cancel each other, because the square root is actually power of 1/2. Same with cube and cube root, right? If I want to get rid of a cube, what do I do? If I want to get rid of a cube, what do I do? What's the opposite operation of cube? Cube root. Cube root, right? They cancel each other to give me x. Why is that? Because it's the same thing as if I raise it to the power of 1/3, right? So what happened here, 1/3 times 3 gives me 1. So that's going to be x to the power of 1. Yeah? So we know the opposite of square is square root. But now we know that when I raise it to the power of a half, that's the same thing as square rooting it. Now, how about if I want to raise it to the power of 1/4? What would that be? How would I write that as a root? The fourth root. It becomes, we start calling it the fourth root, right? So you have square root, we have cube root, and after the cube root we go fourth root, okay? So how about x to the power of 1 over m? How would I write it as a root? The mth root. So you see that whatever goes here in the denominator will be placed in the root. The only one that we don't place is the square because that's my base. The base is the square root, right? That's the only one that I don't write a 2 in the root, okay? Because we know that if there is nothing, it's a 2. Right? Does that make sense to you? Yeah? Let's write things down. There you go. So, to compare the entries in the first and second column of each table, you guys told me that the negative exponent is the reciprocal of the positive exponent, right? The negative exponent is the reciprocal of the positive exponent. And we said that for the exponent a half, is the square root of exponent 2, and the exponent 1/3 is the cube root of exponent 3, right? And then we said that if I have whatever is in my denominator of the exponent, that's going to be the root, the nth root of that thing. Okay? Tomorrow, we're going to go over the little bit more, like we're adding to this. Okay? Now we're going to look at what happens if my numerator is not 1 for the exponent. So what if I have a to the power of 3 over 2? How can I write that as a root? No, that's what we're going to do tomorrow. Because I don't think I should go over this today. Right? Right? I think I can read your face now.